All right, thanks. Thanks, everyone. So we'll talk about extensible SDK, and I'll primarily cover um, what we are trying to do internally, and some of the workflow lapses, how we are trying to fill them in, and also cover the workflow in general. So feel free to ask questions. Here is roughly the agenda. Um, so there are two aspects to it. One is a release engineering aspect. So how do we build it? How do we maintain it? And then the infra aspect, how do you deploy it? And then the developer slash user aspect, which is how do you use it? And I'll go over those and see, what different workflows look like, and also share some experiences, early experiences that people uh, have tried things. So um, basically, one of the issues that you run into is um, when you have large teams, then uh, doing builds on regularly, everybody checking out the whole um, metadata and doing builds doesn't scale at a certain point. The reason is, there's a CI that is running behind you, and especially if components are moving uh, ahead in minutes, or in very frequently, then it's difficult to move everybody in lockstep. And um, and the second problem then they have is that, as if the component goes out of uh, is updated, for example, and then all the dependencies needs to build, and so there's a whole lot of things that starts to happen, and then people start seeing uh, frequent rebuilds and so on and so forth. In many cases, there's a another issue where you have teams who are subject matter experts in other areas, right? So they may be web developers, or they may be graphics developers, not necessarily Yocto engineers, and so it's good for them to use the simpler workflow, rather to say, than to get into the willy-nilly of Yocto and metadata. So usually that happens if you are checking out the full platform build, for example. So as you scale, you have all kind of teams that interact with the system, and that's where eSDK really helps. So this is actually a 3,000-foot view. What we are planning to set up, there is going to be an eSDK server, and then there is basically a mechanism in the infra to expose it to all the build machines and everybody that needs access to it. And then there will be a workflow or some documentation how people can check out the SDKs. And then, different workflows that I've shown here, there are more there, but essentially, if you look at it, it is just to demonstrate that the workflow, or the SDK management remains same. Um, One of the areas where we have trouble with right now, or I'll cover that more, is that finalize step. How it integrates into your Git infrastructure, or your CI/CD, and basically your code flight to accept the code back. All right, so we'll start with building. So that's actually the step one. Right now, what you have is, we actually, you can use anything like for managing your workspaces. We use the Android repo. So basically, people check out using Android repo, and that is the way they set up the workspace. Most of the time, they check out a lot of source code as external SRC, right? Um, and then we have like a pre-commit checks. So there are tons of builds that are happening on auto builders to make sure that the commits are fine. Everywhere they use Android repo for that. And as you can see, if you use something like auto revs and stuff, there is a lot of pressure on the Git server too to serve that much of content. So um, what Extensible SDK also does is it basically decouples that need. Um, and we are working towards that, where Extensible SDK is a installer, that is kind of published regularly, perhaps daily, on some server that basically is accessible to everyone. And then we probably, instead of having those manifests, we will be having a different mechanism to set up the workspace, which will basically download the Extensible SDK and whatever settings are required on top, and then start the developer with that work environment. So essentially, Extensible SDK is a canned build environment, I call it. It still is having everything that you do generally underneath, but it exposes them through another tool called DevTool. And I think Paul has a session today on that one. So highly recommended. That goes very well with this talk. And so how do you set it up? Initially in your distro config, you set up a few things in there, like your SDK vendor and your SDK version. And that's kind of your way to do version management for the SDK itself. And then, you could set your SDK name and your SDK path, which is actually used by your traditional SDK, but then you have SDK ext path, which is basically used by Extensible SDK. And that's the default. So if you want to install it and into default location, that's where it's going to go, into your home directory in this case, but you can specify any path. So if you're standardizing on any workspace paths for your build machines or things like that, then it's better to encode that here. SDK include native SDK, and that is to include all the native SDK components in your SDK. So configuration wise, there is this SDK ext type variable, which basically has two values you can choose. One is minimal, one is full. Full would include everything in it, which means if you are building an Extensible SDK corresponding to an image, then it will have all the content of that image into the SDK. So SDK is big, but advantage is it can be like first time you install it, everything is in there for that particular image. So most of the times, if you're doing bug fixes and not adding new components, that's actually not a bad idea, because then you're not invoking state and everything, state sync rather from the SDK server. So so generally that is what we are preferring, and we'll basically have SDK per machine. For every machine, we'll have an SDK, and we'll use the SDK ext type full. We do have multiple images per machine, and we'll see how that pans out. Don't know yet. So maybe we'll need like SDKs, per image as well, but remains to be seen. SDK include toolchain. So as you can see, this is a variable that is currently set up based upon your SDK type. So if it is full, then what it does is it includes the tool chain in there as well, which is basically including traditional SDK into your Extensible SDK as well. And this is quite powerful, because this gives opportunity for someone to try the cross SDK or the cross toolchain from eSDK itself. So follow the traditional SDK workflow. Say they were to write a new component or something, and they're not yet ready to write recipes and include it in the metadata, and they are just experimenting with something. Then they could basically use this tool chain to do all that work. So we are including that as well in there, and perhaps that will be good as well for if you're looking for cross tool chains to be available. So yeah, once you have those settings, pretty much you build your SDK. It's as simple as building your images, and there is a task called populate SDK ext, and after the build is done, you will see not in the regular images directories, but in your SDK directories in your deploy area, you will have a self-installer that's ready. And the self-installer is essentially a shell script, a shell script, but it's actually an installer. And that is what you really need eventually to use. So so idea is to expose that to somewhere accessible, maybe on a web server or something like that, where people can download it. And it will have versions. As you can see, there is going to be like a follow-up version. So you can have multiple versions of SDKs where people can go back. And SDK is going to be built out of a last good tag, so to speak, which means that that SDK has come out of a system that has been validated with your nightlies or what have you. So there will be a way for people to easily go back to previous SDKs and things like that. Yeah, as you can see, it is a bit largish, around 3 GB in size. So if you're downloading it within your build infra, not a big deal. But if you're downloading it from home, that also would remain to be seen as to how long it takes to download it. But essentially, I think it depends what you include. This SDK has everything in it. So I think that is basically a pretty large SDK. I don't think that will be the normal use case for us also. So once you have it, you will install it. And to install, what you do, you download it from the location that I pointed out previously, and then you execute the SDK installer, the self-installer, right? Once you install it, it asks you a few questions. As you can see, it asks you which directory you want to install it, and you can basically use the pre-existing directory, or you could give it a new one. And in my case, you can see here, I asked to be installed into a different location. The good thing about choosing a default location is that you can make it non-interactive. So there's an option called -y, which means it will say yes. And then you can use -d option actually to give it a directory path where to install. So idea is to basically make it non-interactive at that point, that you can have a work setup mechanism which basically will install it and behind the scenes when the workspace is being prepared. So that is what we intend to use as well. And in the end, what you see is it gives you some progress, and at the very end, it will tell you how to set up the environment to use the SDK. It's very kind of like self-explanatory what it is trying to say there, but generally it's good to document as well. If you change something in there, you could have some files that you can drop in there, so it will source them when it is running. So if you want to add some more in there, it's always good, so developers kind of get more information. You can run into a problem that I ran into as well, and actually we several of machines they run into if your SDKs are big. So there is a solution that I notify max users watches has to be large enough. And once you set that up, there's no space left, error disappears. So that's really good. And I wanted to note here because it took some time for us to detect what's going on there. But the good thing is, if you see, DevTool tells you that what the error could be. So that's really good. We don't get this message from generally normal builds. So because DevTool underneath is trying to run Bitbake as well. But if you were to build an SDK and then do SDK install and all those in the same workspace and to try to do normal Bitbake operations, you may run into the same errors as well. So you might have to change your builders to have this value, put it into your sysctl.conf, and then forget about it. All right, so once you have it installed, then you will set up the environment to use it. And there is the script that you will use to set up the environment. And that's all you need to do. And as you can see, it's asking you, you're ready for your work. And DevTool, as I said, is your interface into SDK. And that is what you're going to use. So next we'll go into using a little bit. And so one of the common command would be DevTool build image. As I said, because you're not building new images, if you're building, that's fine. But if you're not, you just build the same image that the SDK has been extracted out of. And then you could just do DevTool build image to build that. And if it is a QEMU target, you could run QEMU. So you could also do DevTool run QEMU and then give the normal options you have to run it in a QEMU. If you are using a real target, then your normal flashing instructions, they will be valid. One of the difference, as you see here, is that if you have traditional SDKs or the cross tool chains you download from other cross tool chain makers, they will be able to give you a mechanism to build your application, right, and set up the environment, everything, but they will not give you an image builder. And that is actually one of the distinguished features for Extensible SDK, that you can churn out the images, and they may include your changes as well. As you can see here, the build image is pretty fast, because if you have a full SDK, that means everything is in there. It's all canned environment. It's just using that to build your image, and it's pretty fast. And if you look at from a user point of view, their time starts ticking from the point when they check out the source code, and then they set it up, they build it. So essentially, all that, if you account for, then your first experience is pretty neat, because you get an image that you built yourself within minutes to try out. So that's really, really good. And it also uses the same process from a developer's point of view to flash the image, and all those tasks are still going to remain same. So next, I'll go over a couple of scenarios. So walk with me on how the SDK will be used. So I'm gonna kind of show two scenarios and see what all steps are required there. So adding a new component, so that is not so frequent, but common enough. So you want to add a new component, a CC++ component perhaps, or maybe others. So you create your initial source code. So this is actually the component source code, not the metadata like recipes and config files that you want to use in the metadata itself. So how do you go about that, right? So you are seeding your repository, so to speak, at that point. So you could create that repository, and you could use the toolchain that is part of the eSDK to write your initial make files or other things, add your files, make sure it is compiling whatever you're trying to do at the very beginning. Uh, and once you're ready with that, create the pull request or whatever mechanism you have for seeding that repository in your Git forest. Uh, and once that the changes are all in, um, then you are basically ready to integrate it into the platform. So this is kind of a one-time activity for this repository that you will do. You might have certain other kind of workflows to use here. Make sure that when you seed those files, they are matching your policies and everything. But that can still follow. They can still follow the eSDK mechanism to seed it to make sure that on day one it is compilable and can do the initial work that it is supposed to do. In many cases, it will probably be a dummy repo, right? It'll have like maybe a make file, C make file, or whatever they are trying to build for that use as a component build system. But once that is set, um, then you want to kind of integrate that into your platform, and that is writing the Yocto metadata, and that is where you would basically, uh, well, yeah, you could start this where you want to make sure that now you're ready, you can integrate it in, you want to make sure it is installable, runnable, and all those things. So on this page, you see the setup is basically, uh, you add the recipe using the DevTool add command, and you can edit the recipe. That will basically open up the recipe in your editor and give you opportunity to make any changes that the template didn't take care of, and also delete any comments about like it being auto-generated and all those things. Remove them, make sure it is in the shape that you like it to be. And then you can build it by DevTool build CMake hello world. Um, um, Once you have it ready, you can deploy it onto your target in, as you can see here, in my case, I'm trying it on a QEMU target. So what will happen is whatever your installed tree looks like here, it will be reflected onto the image. And then, yeah, you can run all the tests or any other validations you want to make sure on the QEMU itself or on your real target. One aspect is that you need SSH working on your target for this to work. And this could be a challenge if your systems don't have SSH, but that is a prerequisite. I think for us at least, that's not a problem for development. All right, so now you have done two things. You have like seeded the sources, and you have also created a recipe for this, so you could include it in your images. Now, the next thing is actually we need to fill in how do you now give it back into your system, right? So one of the things that, for example, that is specific to us, if you use a tool like Repo, then it's pretty much tied to the Gerrit backend, and that workflow is what it is, but they do have some tooling in between those. So there will be a little bit of changes that people will have to do here. In this case, when you install your SDK, there is essentially no Git. I mean, you have the layers, but they are not under a Git repository. So what you could do is you could initialize a Git repository in one of them, and then you could add a remote, which is basically your upstream repository for that layer, wherever it is. And once you do that, then the next thing, you could uh, do is you can add a recipe by basically DevTool finish, right? So what DevTool finish will do, it will basically take all the metadata that you created along with the recipe and then transfer it to that layer wherever you pointed it to. Once you point it to that layer, you can add it, right? And you can commit it there. And now you have actually created a patch. So based upon whatever your workflow is, at that point, you could use something like Git review and then push it into a Garrett, or you could use, like if you follow a different format, like a GitHub format, you can just push it into a branch and then send a pull request. Or you could use the email works fine too as well if you use like Git format patch. So basically at this point, you are ready to submit it. So we might have to develop some tools around here to have the same experience with how repo was kind of interacting with Garrett. And so we kind of probably have similar scripts to do this kind of canned work for everyone. This is actually only for metadata though. But once you have this, when you modify an existing component, it's way easier. And I'll kind of show you in the next step. And you could also do the similar changes for adding it to images. And once you have added it to your image, you can regenerate your SDKs. And once you do that, and if it is part of your image, then this package will appear as part of your standard SDK next time you publish it. Okay. So this is about modifying an existing package, right? So in the previous example, you saw that we added this component, right? And then maybe now it's a time to fix a bug or something. So again, follow the DevTool workflow. It's pretty simple. You do a DevTool modify. What that will do is essentially, it will take the recipe, it will create an external SRC view for that recipe in your workspace. And it will extract the sources, apply all patches, if any, and create a Git repo for that particular component. So this is, I'm talking about the source code of CMake Hello World. And then it will create a BB pen to point it to in that direction as well. So when you build it, then it is being built from the source that you checked out, not from the normal recipe area. And then you could do the same steps as we talked about, DevTool build, and then deploy, undeploy. That works flow remains exactly same. And then you can go into your familiar edit, compile, debug cycle. So in this case, what I'm trying to see there is that there's a memory leak in there, or I'm just kind of making a change to show that yes, we can change it. Once you go through that, follow the same steps for basically doing all that compile debug step. But the good thing about this is it is already, the Git repository is already created for you. All you need to do is probably add the information about your remotes, so you can push it into your Garrett or GitHub or where have you. And so there will be additional tooling perhaps again to help with that. And then that'll push the changes into the infra, and then all the code flight through CI will ensue. All right, so that's two workflows pretty much that I think I wanted to cover. There might be more, we'll probably discuss that in future. So next, I'm just going to talk again, switching from a developer mode into a release engineering mode. Um, how do you configure SDK update server? So one of the aspects is that, once you install the SDK, you can get your job done and delete it and forget it, and then install a new version next time you work on the same device. Other thing is you can keep it around, and you can use the update mechanism. Uh, and to set that up, you can create a sdkextra.conf in your builder, which is basically building the SDK and publishing it. And then you can set a state mirror and a SDK update URL. Once you set those things up, then this will be encoded into your SDKs. So what that means is now your SDK is basically tied back into eSDK server. And uh, and next I'll show how you would publish your SDK. So there's a command, OE publish SDK, and then you give it a location for where your SDK is, and then you give it a location where you want to publish it. Um, um, what this does is it basically is going to publish the SDK in that location. And next, you will see that you will basically have a feed server set up there. So it is accessible to the build machines which are running the SDK. Then this is what they can do. So they could basically run a SDK update, and any update that you would have pushed in there in the SDK feed area, that will get updated here. So one thing is important, that if you want good experience with them, having access to the state mirror is important, because say, if you're using largest components, right, and you don't expose SDKs state, when they run the DevTool SDK update, it might recompile for them, and that might again deteriorate their experience of saying, hey, I don't change the browser, why is it recompiling for me? So it's important that you expose it, the state mirror, as well as I seen here, into the SDK. All right, so once you update it, you will basically get these commands, and it may take some time, but in the end, you will have everything ready. And then other thing you could do is you could also install a single component into your SDK. So two things, it will look for the shared state, but if it is not there, you can say dev-tool-s, it will basically try to recompile it or try to build it when you want to install it. So this kind of is a mechanism if you want to use new components, and that is what we are kind of hoping that we will be able to use for multiple images that we are having for the same target. As I mentioned earlier, haven't done much with that yet, so don't know whether, how far it's going to go. All right, so that's all I had for the SDK that I wanted to cover. We can take some questions now.